everyone, welcome to Success Bridge YouTube channel. Today we are discussing about Karnaugh Map is nothing but K-Map. What is K-Map? K-Map is a pictorial format or graphical tool that simplifies the Boolean expression. Without using laws, we can solve the Boolean expression with the help of K-Map, developed by Karnaugh in year 1953. This is the representation of K-Map. The binary codes are arranged in gray code sequence. As you can see here, 00011110. This is the gray code sequence. Everyone have one doubt that why we taken 1 here instead of 10. The reason is every state need to change only the one bit. So here 00 to 01, one bit is changed. After coming to the next state, 01 to 11, again one bit is changed. In this way, we are arranged in the gray code sequence. We can solve with the help of K-Map the expressions. Here K-Map have two forms. First form is SOP form, sum of product. Next POS, product of sum. Here we have some steps to solve the expression by using the K-Map. Let's see the steps. First step is the K-Map according to the number of variable. Need to select the K-Map. Okay, when given in the problem the number of variable, by seeing the variable we can select the K-Map accordingly. Second step is identify the terms. This is nothing but min term or max term or SOP form or POS form as given in the problem. The next step is as given in the problem, like SOP form, then the grouping is done as once grouping is done. When in the problem is given, next step is when is given in the problem as POS form, then the grouping can be done as zeros grouping. As you can see in the figure, there is a SOP form. So in this SOP form, we are grouping of once is done, right? Next step is make the rectangular grouping containing 2 to the power like 2, 4, 8. Means we can grouping can be done 2, 4, 8 or 2 to the power and cells. If it is not grouping any one of these, only the presence of only single, we can group a single grouping must be grouped. Cell containing one must be grouped. As you can see here, two grouping. Here the corner grouping of quad. This is the octal grouping. This is a where cell containing only the one must be grouped. As you can see the single grouping. Next, from the group made, fifth step, find the sum product term and sum them up for the SOP form. Okay. Next, as you can see, this is the 3 variable K-Map. As you can see here, the overlapping is group is done. This is how we can do the overlapping. These are the few steps to solve this expression using the K-Map. With the help of these rules, we can solve our problems. Let's see the minimize of 3 variable K-Map. Here the F1 is equal to summation of 0, 1, 3, 5. So in this case, the Boolean function contains 4 midterms. So first of all, let us represent all the 4 terms in the K-map. So for that you need place ones in each cell which represent these min terms, that is 0, 1, 3 and 5. And now let us try to minimize it. So here is the first group of ones. Similarly, we can make the grouping of twos ones, and now only the ones is remain. So by making this grouping of twos, we can also cover that one. So in this way, we have covered all the ones in that map. So let us consider the first group. This is the first group. So as you seen earlier, in this group, the variable a and b is not changing. But while the variable c is changing, and here the value of a and b is equal to 0, therefore the grouping represent as a bar dot b bar of first group. Let's see the second group. Similarly with the second group, while variable a is changing 0 to 1, while the variable b and c remain the same. Here the value of b is equal to 0, while value of c is equal to 1. Therefore, this group represent b bar dot c. Similarly, the third group of variable a and b, a and c is not changing, while b is changing. So here value of a is equal to 0, while the value of c is equal to 1. Therefore, this grouping represent a bar dot c. So now the overall function is summation of all this group, that is a bar dot b bar plus b bar dot c plus a bar dot c. So in this way, using the K-map, we can minimize the Boolean function. Thank you.